All right, so I wanted to show you guys a little bit more about how to play with Desmos if you wanted to for our logo challenge. So remember, for our logo challenge, you need to have 3 functions, 2 transformations, and also you need a domain restriction. So in class, I started with a circle. Here I'm starting with a ellipse, which technically is a circle with a vertical, or in this case, I guess we have a vertical trying to think of what you would call this because you have the 4 under the x. So this would have started as a 4, 4, as if we had this as a 1, right? We would have had this as, yes, yes, I'm here. I'm with us now. We would have had this as a circle centered at 0, 0 with a radius of 4. And technically, we could call this an ellipse as a whole new parent function, but really when we multiply by this 1/4, we're coming in here and we're saying, okay, original circle, let's multiply this by a 1/4, and we're multiplying the x term. And what we found is if we multiply the x term, it works in the opposite direction we would expect, and it's going to happen horizontally. So we get a horizontal stretch in this case because the 1/4 seems like it should make things smaller, but in reality, going back to the original x's, it makes things bigger. So we see this stretch going out instead. So and really, if you look at the stretch, we went from 4 to 8 instead of 4 to 16. And that's because if we really wanted to put this inside of the actual x portion of what was happening, we would have done this as x over 2, right? That would have given us the exact same thing. Let me get rid of the 1/4. And so now we could think of it as a circle with a horizontal stretch. But lots of different ways to get to the same thing. This is one way to call this both a parent function and knock out one of your transformations, but we shouldn't have any trouble because we're going to have to transform other stuff to move them around in here. So the other thing I wanted to show you, and I'll give you guys a link to a really long but cool and very fast Desmos thing where they went through and showed how they had these new colors. So I went ahead and just defined K as my color because that's the one I'm going to use. And I'm trying to create a color I like better than the ones that they had. So if I hold down this little thing next to it, whatever I've made, I can change the color of it. So that way I can make everything the same color, and I can actually choose this cute color I just made, this sort of greeny, gray bluish color. So I'm going to use that, and I changed the thickness because this line was not terribly thick. I changed it, oh no, to an 8 thickness. So now I can add more to this. So I've got my ellipse. I might want, as we saw before, to have, if I'm trying to put a K in here, I'm going to use a vertical line, probably at that -4. It looks pretty, so let's do x is equal to -4. I'm going to click this and hold so that way I can get to change the thickness to an 8, change that color to match my cute color. So I've got my second function, and now I'm going to want to go ahead and do a restriction because I really would like this to only be within the circle. So this is one of those situations where I could solve out the actual equation, I could guess and check, I could get pretty dang close. It looks like we're at 3 point something, so let's try -3.7 y to +3.7. So I went a little bit past. I can guess and check. Nope, that's not enough. Okay, 5 doesn't look too unreasonable. With that thickness, I could probably do 4 and get right inside of it. So I'm not actually solving out that equation, though if I wanted to be really classy about it, I could. And actually looking at this, oops, let me hold this down. It looks like I've got a transparency here because you can kind of see through that particular value. Another thing you can do, if you want to, you can use inequalities to shade your logo. So let's say I like that line, but I want everything shaded to the left of it a certain color. So I would say x is, uh-oh, I lost my monitor. There it is. X is less than. It's going to shade everything below that. It just gave it a dashed line, so I should probably throw my equals on. But I would also want to make sure that it's within this little range. So I might have to solve the other piece of this so it stops, right? So I need to be like, okay, well, it's also got to be greater than. And then I want it to stop at the edge of that other one, but I've got to solve that out. So what is that? The square root of 16 minus y squared. Oh, my poor brain. And what else do I need? Times 2? I feel like I'm still missing stuff here. It's obviously still mad at me. So I have to think about what I screwed up in that piece to have it not stop. All right, so for a second, I'm just going to take off this domain restriction, see if it's causing me my problems. It is not. What if I get rid of this piece? Oops. Oh, I did the wrong side of the curve. Ah, now I see my problems. Let me add those things all back. They were all good. I just needed a negative out in front. Dork. Yes, there we go. And again, I'm going to make this an equal to so that I have the solid piece. So you can do shading if you want. I just want to throw that out there. Again, if you hold down, you'll be able to change the transparency on that fill. Maybe you want it lighter. And then I can change the transparency on that line so it's super thick. So right now, I've got a domain restriction. I have two different families of functions. I kind of fibbed it and made my ellipse into a transformation. So I only got to get one more function here and a transformation to that function. So maybe I do an absolute value function. Because here's the great thing about Desmos, I can use functions that aren't functions. I can write things in terms of x instead of y, and that's going to make life a lot easier for me because now I realize if I want to shift this over, oops, wrong direction, that's great. I can make my k by using an absolute value function on the y instead of the x and incorporate a shift. Again, I want it to stop here, so I don't want it to have any x's where x is less than or equal to 0. I don't want it to go past that. In fact, maybe actually I'm going to change this up a little bit. I would like this to be a little narrower, and then let's go a little further. Let's see. I'm trying to figure out where we cross. 2.5? Again, this you can guess and check, or you can be better about this. It really is fine. 3.1? 2? There we go. All right, and then I'm going to go ahead again, hold this down, change it. I'll make it a fat line, make sure it isn't at all see-through. There we go. And then I can play around with this too, right? This might be even easier since I have this to say I want this piece to be less than. Oops, I lost my less than. Oh, wrong way, greater than. So this is a great thing. You could just keep going on and try things. But that doesn't get us the whole thing shaded. So maybe I don't want to deal with that. I'll just leave the equals in the K. But now I've got, look, two different transformations happening to that one graph. I've got a shift as well as a stretch, so I can feel a lot better about what I've done. So maybe your logo looks something like this. Maybe it's more fun. I just wanted to give you guys that tool of being able to hold this down to change the thickness, change transparency, the idea of using inequalities to get this sort of cute shading if you'd like it, and then this little RGB hack where you can just make these little sliders where you can change the color of your graph really quickly and see if there's something you like better than what's already that hurts my heart, my head, where you can change the color of your graph up. So hope that makes that a little more fun for you. I see a bunch of you have already turned that in. I'm going to extend the due date until Tuesday since we don't have class on Monday anyways, that we have a little bit more time. And then I'm going to go start making you guys a bunch of videos for chapter 2.